Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Pompeii by Kafka Farnham. And here are the rules. We have yin-yang shading, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected, and no 2 by 2 area is fully shaded or fully unshaded. So this is an example of a valid yin-yang shading, because all the shaded cells are orthogonally connected. And what does that mean? Is that you can get from any shaded cell to any other shaded cell just by going through edges, all while staying within the shaded region. So for example, if you try to go from here to here, you can just go along this way, and it would always go all through shaded cells, all while going through edges. And the same thing is for unshaded cells, which is why this is valid, because you can go from any unshaded cell to any other unshaded cell just by going through edges, all while staying within the unshaded region. And we finally have no 2 by 2 areas fully shaded or fully unshaded. So this would not, this would not be a valid yin-yang shading, because we would have to go from these cells to the other unshaded cells through a corner, or we'd have to go through the shaded region, which is not allowed. This is not a valid yin-yang shading, because we have a 2 by 2 area that's all unshaded. And we can't, again, have a 2 by 2 area that's all fully shaded or all fully unshaded. So that's yin-yang shading. And in addition, in any given 3 by 3 box, any digit that shares the same yin-yang nature, that is shaded or unshaded, as the 0 in that box will have a value of 0 for the purposes of Killer Cage sums. So that means if we have a 0 here and then these other cells here, you had, say, I don't know, 6 and 9 or whatever, the value of this 6 and 9 is actually 0, because it is the same shading as the 0 in its 3 by 3 box. And if we had a 0 here, the shading of this cell, of these cells here, would also be 0. Or sorry, these unshaded cells would be 0, right? Because whatever the shading of 0 is, all the other cells that are shaded the same way must have a 0, must be equal to 0. Okay? And we have every row. This is doppelganger rule set. I've never run into this, so I don't know which there's another type of doppelganger rule set, but this is a different one, I think. Where every row, column, so every row, every column, and box contains the digits 0 always, as well as 8 out of the 9 digits from 1 through 9. That is, it's missing a digit that is not 0. So every row, column, and box contains, so how would I put this? In every cell in the grid, place a single digit from 0 through 9, such that every row, column, and box contains the digits 0 and 8 out of the 9 digits. Well, So there must be a 0 in every row, column, and 3 by 3 box. I should put it that way. We need to fill in the grid, fill in every cell in the grid with a digit from 0 through 9, such that there are no repeats in any row, column, and box. I guess I would put it that way. And then no 2 rows, no 2 columns, and no 2 boxes may be missing the same digit, which is why we have these things here, right? So this indicates what digit is missing in each row. These indicate what's missing in each column, and these are indicate which digit's missing in each box. So there are no repeats in these sets here, right? And for each 0 in the grid, the digit missing in its row, its column, and its box must be 3 different digits. So say we had like a 0 here. The digit missing in row 1 then would have to be different from the digit missing in row column 9, which would be different from the digit missing in box 3. That's interesting. I've done similar puzzles to this before, but this is like the first of its type that So each of those digits relating to each 0 must be different for its row, its column, and its box. That's for the digits missing. And finally, we have killer cages, where in cages, a digit may not repeat. Oh. In cages, a digit may not repeat regardless of the value they take. And their value, per the special yin-yang rule above, must sum to the total in the top left corner of the cage. So, for example, these 5 digits here, there cannot be repeats in the cage, and the values of those cages must sum to 2. The values of these cages must sum to 17. The value of these cages must sum to 8, 6, 10, etc., etc. But remember, the value of every shaded cell, every cell that's shaded the same as the 0 in the box have to be 0. Whereas the value of the digits that aren't shaded the same as the 0 in the box are different. Are the different digits, essentially. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, we have a cage here which has 10 digits. So, it must have the digits 0 through 9. So, that means whatever digit is here is the missing digit that's in the upper box 3. Also, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. So this is also missing. This is also the digits 0 through 9. So that means this is at most, to add up to 4. I think it has to be, you can't have, so you could have, so 0. 0 is obviously fine. You could have a singleton 4, but the problem is if you had a singleton 4 and just had a single 4 here, either it's here, but then this 3x3 box is all the same shading, or it's here, 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 here. But again, you can't have in this 2x2 box or this 3x3 box. You have to have at least 2 that are the same shading, which are different from the others. So that means that I think it has to be 1 and 3, right? And the thing is, the shading cannot be going this way, because if it went this, it cannot be here, because then so the center cell has to be a different shading than everything else, and then it must go out of the box. But if it tries going out this way, it could go out that way. So we know this is one shading, and this is a separate shading. You can't have 3 digits, which add up to 4, because again, you don't have the 0 with it. You have so it would be 1, 2, 3 at minimum. So it has to be a 1-3 pair. This could go out this way, and then this is the same shading as the 0 in the box. We know this is blue. That's interesting. So this is 1 or 3 here. So this is also the digits 0 through 9. These two add up to 18. So this must be an 8-9 pair here. This is 17. So this is 10. So these must be the same shading, and they cannot be the same shading as 0. Right, so these are the same shading, and they can't be the same shading as 0. We'll mark those as pink. Same for this. This is the same. Well, we don't know if they're the same shading, but they're valid shadings. We're gonna mark it pink and yellow, I think. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are also the digits 0 through 9. And only one of them only one of them can be shaded. Or it's the same shading as a different shading. Excuse me, as 0. So these are, we don't know. At least 3 of these are the same shading. These all have to be the same shading. We don't know, though, which way it goes. I guess one of them doesn't, right? We know these 3 are the same shading, though, because of that. Which means this is the opposite shading, so this counts. This has to go out some way, so this is at least 2. It could be 3. 12 has at least 2 that count. 10 has 2 that count. So these are still valid. So here is, you have 1 that counts. So this is also shaded that way. Okay, so for one thing, for yin-yang shading, once you swap from one color to a different color, you can only swap twice on the edges, right? So if you try to have, so say we had a green area here, right? And then say we swapped again here. Say we're saying that this is all blue, and then we have green and green. How do you connect the green areas together orthogonally, and yet also have all the blue areas connected orthogonally too? You can't. That's why you know that you can only swap twice on the grid edges. Of course, we don't know what the shading is, what the grid swapping is for each shading, right? So we don't know if this changes or if this is stays in the same shading here. We know 2 out of these 3 at least are shaded. We know both of these, sorry, these are the different shading than 0. This is different shading than 0. This is different shading than 0. This is different shading than 0. We know 2 out of 3 are here. These are, so this has to be, we're gonna mark it, I guess maybe we should mark it as green. But the problem is, yeah. We know one of these is a 1. Okay, so this has to be a guaranteed 1 here. 2, you have to have, it has to be guaranteed 2. So you have a guaranteed 2 here, and you have a guaranteed 2 here. So since you have a guaranteed 2 here, this cannot be 2. But you could have a 2 here, and then this be 1. That's possible. We know we have a guaranteed 1. Well, this is 0 through 9 here. So this is guaranteed 0 through 9. And so this can't be 8 or 9 in box 4. This can't be 8 or 9 in column 2. Can this all be the same shading? I guess. Four out of 5 of these are the same shading. 2 out of 3 are the same shading. Excuse me. So obviously, this has to have at least 3 of the different shadings than this. Because 3 out of these at least do not count. It could be more, right? This could all be the same shading here, and then this is just different than the 0 in the box. In this 2x2 area, there can only be, you have to have one that's different shading than the others. Same with this 2x2 area. So this has to have 1 and 2, right? So you're guaranteed a 1 or 2 here. You're guaranteed a 1 or 2 here. The rest of these are not counted. But these could be different shadings of 0. We don't know. So this has to be 1 and 2. This has to be 1 and 2. Interesting. But the 1 or 2 could be different, I guess. Right? This is also 1, 3, either one way or the other way. So if it's 1, 3 this way, that means this can't be 1. We know we have 2 out of 3 here that are shaded. This could be 1, this could be 1, this could be 1. This has to be 2 out of 3. Or 1 out of 3, we don't know. This is 2 out of 3. Okay. So 1 out of these 2 is valid. Can it ever be 2? We know this is valid, this is valid. So if we had 2 here, this would have to be blue. We'd have to have blue there and blue there. Interesting. but it could just be 1. And can it be 1 that way? I guess it would have to be blue. Huh. We know these are the same shading, guaranteed. These are the same shading, these are the same shading. This is one of each. We know it's one of each here. This is not counted. So this is value 0. So all the blue areas are value 0. All the green areas are valid values. These is valid. One out of these is at least valid. Ah, no, it can't be 1. It has to be... One of these has to be a 6 then. So this swaps here. So this is a shading swap here. Guaranteed. Interesting. Because otherwise this 2x2 area would be all the same shading. So this is a swap here, which means this is a boundary there. Oops, let's make it red. Do we have any other area that's like that? I don't think so. Technically, this could be one size and that's it, right? So it could be like all blue here. That's possible. Okay. So this cannot be 6 in box 4. So the missing digit in box 4 has to be 1, 2, 3, 4, 5, or 7. We're missing... We obviously can't miss 0. In box 3, we're not missing 1 or 3. So 2, 4, 5, 6, 7, 8, 9. In box 5, it's 2 through 9, because we can't be missing a 1. Okay. I guess these could both be valid, and then this is valid. If this switches the 0. The 0's in a different shading here. That's possible. One out of these... Okay, so one thing is this cannot swap and then swap back. I guess it could be blue, blue. Wait, so say this swaps to the other color. I guess it could still be that way. And then this is all the same. Right. Yeah, because the thing is, this would have to be essentially the... the one would have to be somewhere in one of these 3, right? Then this would all be the same as that. This could all be the same shading. This could all be the same shading. So it could be 3 digits here adding up to 12. These could all be different shadings, though, here. Right? We just know that they add up to 0. But that doesn't tell us too much. Okay, let's just delete this. This is not useful. Having that many digits. So we really want to look at places for where you have one cell, right? One of these is guaranteed to be set. One of these is guaranteed to be set, and that's all we have. Hmm. This digit is obviously 1 through 6. This cannot be 1 and 9, so this is either 2, 8, 3, 7, or 4, 6. This could be 9 and 1. So 9, 1, 2, 8, 3, 7, 4, 6, 2, 8, 3, 7, 4, 6. So this is the same. 9 and 1, 2, 8, 3, 7, 4, 6. There has to be a 0 in every row and column. Okay. Well... So this is valid. One of these is valid. Both of these are valid. That's valid. Only one out of these cells are valid. It could be here. Oh, no, this is invalid. This is invalid. Because this is invalid, but the thing is, it could be still going that way. So for this cage, this is invalid. This is invalid. Therefore, if this cannot be both valid. If they're both... Sorry, they cannot both be invalid here. Because if they're both invalid, then this 2x2 area is the same shading. So one of these is valid, which means this has to both be invalid. And this shading, I guess it does exit out that way. It could potentially exit out that way. Okay. It could exit out that way. So either this is valid, which means it's a swap, and then these are invalid. Oh, that's interesting. Okay, that's not possible. So if this is valid, this has to be invalid, and this is invalid. Well, if this is invalid, it swaps then here. I guess this could be the same shading. Then same shading. Then same shading. Same shading. Same shading. That is possible. It could be that this is all the same shading, and then it swaps in different value, right? One of these, so one of these is... Okay. So say this is valid here. Both of these are valid. If both of these are valid, this is invalid, this is invalid, and this is invalid. So we have a swap here, then, if that's the case. So we have a swap here. This would all have to be the same invalid. This would be the same shading. So then this would have to match this. Because then you have the swap here. So then these would all be green. So these would all have to be green. And is that possible? So these would be all valid. This would be green. This would be blue. Valid would be green here, so this would have to be blue. This would also be blue. This is all blue. We don't know what the shading here is. That's still the questionable. This is all green. We don't know what the shading here would be. So this would have to be blue here. This would have to be all invalid. You can't have 3 digits here adding up to 2. So then this would have to be a 3 in that instance. This would be invalid. These would both be, this would be invalid. So this would have to be valid as at 8. So that would be blue. So that's the same shading. But this is invalid, this is invalid. These are both valid, so it's either 2, 4, or 1, 5. And this would be 5 and 1 if that were the case. So there's no 3 here. This would have to be valid. These would be invalid. So this would be a 1. So this would be 1, which means this could not be 1 and 5. This would be a 2, 4 pair, which eliminates 2 and 4 in the rest of the box. No 2, 8 or 4, 6. No 2, 8 or 4, 6. This can't be 2 or 4, so this can't be 6 or 8. This is 1. 3 eliminates 3 here, so this would be 1. It would have to go this way. So then this would be blue, blue. This would be green. This would be invalid, though. This would have to have a 2 here to be valid, because we can't have a 1. So we need a 1 in one of these boxes, so it would be one of these. So this cannot be 2 and 8. It cannot be 1 and 9 in this instance. So 2 eliminates 2 here. So this must be 4, which makes this 2. This can't be 4 and 6 here. This can't be 4 and 6 there. So we know this is green here. Ah, and then we have a contradiction. Because green... No, we don't. This is blue. So this would have to both be blue. Because in this 2x2 box, only one of them is valid. And valid is the green. One of these is valid. This is invalid here. These are 0, essentially here. This can't be 2 or 4. This can no longer be 3 digits adding up to 6. Because we have 2 and 3 here, right? One of these has to be a 6. So it has to be green, green here or green, green that way. This is not valid, so these have to both be valid, but we don't know which ones. It's 8 and 9, though. This is definitely a 1. This is a 1. Full 3 adding up to 12 without a 1. I think it has to have a 2 then, if that's the case. Which means... No, right, no 1, 2, 9, no 1, 3, 8. No, none of the 1s. So start with 2. 2, 3, and 7's possible. 2, 4, and 6. Oh, it could be 3, 4, 5. This is 1 and 3 here. So it does not have to have a 2 here. This is looking like the solution, to be blunt. Um, hmm. So this is all zero value. We don't know about these. It could be the blue here is not the same as the zero. Hmm. Only one out of these three is valid. So it could be blue, green, blue, potential. Well, green is not the same shading as zero here. Green is the same shading as zero here. Green is the same shading as zero here. Green is the same shading as, blue is the same shading as zero here. Green, same shading as zero. Here we don't know. um, hmm. Hmm. So far, it's looking okay. Hmm. Hmm. So this is... don't know. I was hoping it... Oh, this is 2 guaranteed, so this can't be 2. Therefore, this becomes a 3-7 pair, which eliminates 3 and 7 in the rest of the column. So this can't be 3 or 7. This is 9, which makes that 1. This can't be 3 or 7. This is 6, which makes this 4. Okay. So in column 5... Ugh. One of these is 2. We're missing either. So this is 1 guaranteed here. And you could have 0, 5, or 8. And this is 2 guaranteed here. 0, 5, or 8. So we're missing 5 or 8 here in column 5. Digits may not repeat regardless of the value they take in the cages. Okay, so there's no 2 here. There's no 2 here, obviously. One can't be here. One can't be here. Oh, that's interesting. That's not true. We don't have to have zeros in cages. Yeah, we don't have to have zeros in cages. You could just be basically the same shading as a 0 in a cage. Okay. So this is 237, 246, or 345. We don't know which. If these are both green, then this has to be blue to connect out. If both of these are green, the problem is this would have... So if this is green, this would also have... This would have to be... If this is green, here. The problem is green in this box out at is a value of 0. So therefore, this would have to be the blue here. No, sorry. It would have to be valid value here. But blue in box 6 is value 0. So therefore, this would be green, green. So this cannot be green here. Therefore, this must be blue. Since this is blue, this has to be green. So this is value 0. This is 2. And so this has to be a 2 here, which eliminates 2 here and 2 here. That and 2 here. Therefore, for this has to be 2. It has to be green. This cannot be 2. This has to be 3, 4, and 5. This is looking like a valid answer here. This cannot count. So this must be green. Oh, hold up. No, this has to be blue. That's blue. Okay. Right, this cannot count, so it's blue. One of these is green, and is a 1. Okay. One cannot be here. Well, we obviously know that. One of these is valid. It could be this one. So this is valid. This is invalid, so this must be blue. Because we have the valid one being there, because this can't be 2. One is here. This is looking like a valid example. Do we go off a different path then? This has to be 2. Because it has to be green going out this way or this way. So one of these is 1, 5. So it's either 1, 5 here or 1, 5 that way. This is valid, so it could be... It has to go either this way or this way. We don't know which. This cannot be 1, 3. This could be 2, 4, 5, 6, or 7 here. One of these is green, one of these is blue. This is valid, this is valid. So either they're both blue or they're both green. That's interesting. This is valid, so this is green. Okay, so then it goes green, green, which means the other one is blue. Okay. One cannot be here. So one has to be one of these 3 here. So this is not valid. This this has a value of 0. That's not helpful. We don't know if it's blue or green. It's opposite of these. So then let's make that pink and orange. We don't know which one's which though. We'll make these yellow, pink versus yellow. One of these is 1. Um, it cannot be here. If this is 1, that means the rest of these are value 0. This would have a cross diagonal, which are the same, but then this would be cross diagonal, which is the same. And you try to connect those parts, it doesn't work. So this cannot be 1. This is looking like the solution, to be blunt. I don't know. It's one of these two. So obviously, if it's there, that means this connects as a blue and this is green. So these must be opposite. So this is orange. So these have to be opposite, so this must be green. Since this is green and this is green, this has to connect green that way. Otherwise, you'll have a cross here. Actually, no, it could go this way. Dang it, okay. We know this is green. We don't know what... Is there a better way of going attacking this? Because this is looking like this is possibly the solution. Hmm. Box 6, we're missing 6, 7, 8, or 9 in this case. Hmm. Hmm. This can't be two correct values. If this were two correct values, this would have to be a 1-3 pair. Sorry, non-zero values. Okay, it would have to be a 1-3 pair. So this must be a 4 here. So it's guaranteed to have a 4 here, which means this can't be 4. Hmm. So we'll only have 1 here. You could have 2 here still. So this is a blue-green pair. Don't know which is which. It had to be that way anyways because this was both blue. One of these is not, but it could be here. Yeah, this is looking like a good assumption because it's not leading to contradictions at all. Okay, let's go down a different path because right now it's looking too valid. I don't know, maybe there's a contradiction somewhere further down, but I don't know where it would be. Okay. What other assumption can we make? Okay. We know those are blue. Maybe that it swaps here or swaps here. Right? So say this is green. That's a swap there. So this would have to be green, green. All of this would be blue then. So then this would all have to be blue. Which would mean that's green. So we have a similar situation here, right? This would obviously, so these would not be blue. These would be green. These would be green. Because the valid ones are blue in those boxes. We don't know what that would be. We don't know what this would be. So this would again be 3. This would be 1. This couldn't be 1, 3 this way. Therefore, this would have to be green, green. Seems fine. 1, 3. That's interesting that we always sort of run into that scenario that way, right? Here. These are all blue, so this cannot be 2. The 2 is one of these, 2 is one of these. This can't be a 2-8 pair. Blue is valid here, which means blue is valid here, so this must be a 1. Ah, interesting. So this is blue. And then this is all invalid. These are valid. Interesting. This can't be 3. No 1 and 9 here. Both of these cannot be blue. So 1 is green, 1 is blue, and then it's a 6. So this cannot be 6 here. This can't be 6, so this can't be 4. This can't be 4. 6 is a pair. One of these, so one of these has to be blue and green. 1 each. Because these are all blue. Blue and green. One of them's 2. Blue and green. Since this is blue and green, that's the other one here. Oh, blue is valid here. Oh. Blue is value 0 here. Blue is valid, non-zero value here. And then we have a contradiction. Okay. Because this would have... Both of these cannot be blue. If this is blue here and this is green here. Oh, it's not contradiction. It could be green and green here. It just can't be blue and blue. Oh, same with this, actually. That's incorrect. This one does have to be blue and green because of the blue. The blue counts as something here. But if this is green and green, that works. Green is non-zero value. So then this is 2. This cannot be 2 here. So this must be 2 here and be blue. So that's blue. This has to not count, so this is blue. And this must not count, so this must be green. Well, we have green. Well, we don't know what that is. This is blue. We don't know what that is. We don't know. One of these is blue. The rest are green. Okay. This is blue. This is the 1. Okay. 1 cannot be here. So this is 2. 1 cannot be here, so 1 has to be here. Which means both of these are green. Because one of them at least has to be green, and we can't have... They cannot count either way. 1 is blue, 1 is green here. So we have 1 blue, 1 green here. This is green and green, so this must be green there. Therefore, this adds up to... This is only 1 green here. This has to be 2, 5, or 3, 4 to add up to 7. Cannot be 3, 4, so this must be a 2, 5 pair. Because we have only 1, 4 here. This cannot be 2 and 5. This is 1, this is 1. That means 1 cannot appear in box 4 at all. Because it can't be in rows 4 or 5. It can't be in this cage because we already have a 1 in the cage. So therefore, in box 4, the 1 would be not in 4. Therefore, 1 would have to appear in box 9, so it would be one of these two. It would have to appear in box 2, so this would have to be a 1-9 pair. So this would be 1-9. Two cannot appear here. This is looking valid too. Jeez. Oh, no, that doesn't work. Because we know 1, 9 are non-zero values. This must be non-zero value, and therefore, but we had the assumption there. And I think that's the same. Maybe not. Hold up. Okay. So this has to be a blue. Here. So this has to be blue there. Guaranteed. We tried to make that green. And, yeah, the problem is, if this is green, it switches here. It has to switch here. So then this has to be all blue. And because this is all blue, these count as non-zero. This must also count as non-zero, and then we have a contradiction. So that was that way. Okay. So this is definitely blue. If we swap here, we need to swap here. So then this would be green. All of these would be green. That's interesting. Ah. And then we still have the contradiction. Because these would be the same set. So if this is... Okay, so if this is blue, this has to be... Sorry, if this is green, this has to be blue. This swaps here, which means all of these are the same. And because all of these are the same, this must be a non-zero value. And therefore, it would have a problem. Right? Same with this. If this is blue, if this is switching to green, that means it swaps here. This can't swap anymore. So these all have to be the same. This would have to be a valid value instead of 0. So this would have to be 1. But then this would be 1. So these are both blue. Which means this has to be 1 here. So this is guaranteed to be a 1 here. So since this is 1 here and is a valid value, this cannot be 1 here as the valid value. So this has to be invalid. So we know there's a swap here. Okay. So we'll make this, I guess, the green. So this has to be all green, which means this is blue. This has to be blue. So then this is all blue this way. So this must be the same. So this is blue, which means this is green. So we're going to mark the 0 as the color that is in this box. So this is blue. 0 is blue here. Green has to be the 0 here. Blue's a 0 here. Green is a 0 here. Blue has to be 0 here. Green has to be 0 here. Green is 0 here. And we don't know for this one or this one. So this one we'll mark as pink. This has to be blue. This it will mark as pink also. And we'll mark that as orange. So this is blue and blue. This has to be a green. And therefore has to be 3. So this is still the same. This is 3. This is 1. So that must go this way because it must be 1 and 3 adding up to 4. So this is green and green. 1, 3. This has to be blue. So yeah, we did get down that path. Okay, so this is 2, 3. Okay, so 1 cannot be here. This has to have a 2 here. So this cannot be 2 and 8. Couldn't be 2 and 8 because anyways 2 can't be here. So we had to have a 2 here and a 2 here. Again, if we try to have this being blue, this would have to be blue because this blue is 0 value. So we need a 2 somewhere in this cage. And that would have to be blue, blue, blue. So this must be green, actually. And the green here adds up to 0. So 2 can't be there, which makes this the 2. So this can't be 2 here. So this must be 2 here. And therefore it's blue. These must be 0 values. So that's blue and this is green. Not red, green. Okay, so this is blue here. We don't know whether the 6 is... One of the 6 has to be one of those two. This can't be 9 and 1. It can't be 2 and 8. So it's 3, 4, 6, or 7. Yeah, so we're kind of running into the same thing. 1 has to be the 1 here. So this is 1, which means these cannot be valid. So these are green. One of these is blue, one of these is green here. We're not sure which is which. One of these is blue and green. And this has to be a blue-green pair also. Again, this can't be 1, 3 because we have 1 and 3 eliminated there. So this must be a blue-green pair. And the 4 must be here. So this cannot be 4, cannot be 1, 3. So it's 2, 5, 6, or 7 here. This can't be 3. Let's see. So this is 2, 2. Oh, this can't be 2. So this is 3, 4, and 5. There we go. So this is 3, 4, 5 triplet, which means this is 6, 7, 8, or 9 as the excess digit. One is here. 1 is here. 1 has to be one of these 4. So I can't be here. So again, 1 has to be one of these 3. This is an orange. It cannot be 1 here because then this would be valid. So these would be the same shading, and then these would be the same shading, and we can't have crossing there. So this must be orange also. So this is all still the same. Okay, so yeah, this is still valid. Okay. We can remove the boundaries. Okay. So one is one of these, which means the other one is the opposite. So this is blue guaranteed. We don't know about this. Could they all be the same shading? No, I mean, they could be all different shading and still all be valid. Okay. Blue, blue. Hmm. This digit has to be one. Okay, hold up. Yeah, this could be. Whoops, this is shading. It could be 1, 2, 6, 7, 8, 9 in column 9. 2 is one of these two. 1 is one of these two. So this cannot be 2 here, which means this can't be 8. One of these at least is blue. We don't know which. These digits, one of them could be 0. No 3, 4, 5. So this is 0, 6, 7, 8, 9. It's possibilities there. Huh. We have a guaranteed 1 here. Whatever digit is missing from here in box 3 has to be in this digit here. So this is 2, 4, 5, 6, 7, 8, 9. That's not too helpful. One of these must be blue. So it can never be 6 here. It could be 1, 2, 3, or it's 1, 5, or 2, 4 as a pair. Huh. Pink. Okay. So this we know is a boundary here. Obviously, this is a boundary there. Is that helpful? Not particularly. Oh, and this couldn't be 2 greens anyways, because this is double green there. Okay. Oh. This is a 3, 4. This is one of these digits is 3 or 4. That means one of these cannot be the 3, cannot contain 3 or 4. Well, it can't be 3, 4 here, so this must be a 3 or 4 here. Which means the other 3, 4 has to be here. This is 3 or 4. This cannot be then 4. Can't be 2. So 2 has to be in, so 5, 6, 7, 8, and 9 must match this cell here. So this is A. We're going to make this A here. And this is A. So those have to be the same digit. This is 3 or 4. Where's 5 then in this cage? 5 has to be here. So 5 has to be here, which means this can't be 5. So this is 6, 7, 8, 9. The other 3 or 4 is here. That means whatever 6 or 7. So so A has to be, A cannot be here. So in this cage, it has to be one of these 4. So A has to be one of these. We have 5, 3, 4. There's a 6 or 7 relating to this 3, 4 here, which has to be here. So we have 1. So there's a guaranteed 0 here. Okay, so this is 0, which means 0 cannot appear in the rest of this cage. So because of that, this can't be 0, and this must be a 0 here. Okay. So this 0... we're missing 4, 5, 6, 7, 8, 9 here. We have 0 matching the 6 here. We don't know what's missing. It's missing a 6, 7, 8, 9 in green. It's missing some other digit in column 8. So this cannot be both blue. So if this were blue, that would mean it has a value of 0, which would force that to be blue, which would have a value of 8. But then you'd have a 2 by 2 area that's all blue. So this cannot be blue. This must be green. Since this is green, this still could be... No, these two are green across each other. So therefore, you can't have a blue here. So this must be green this way. And green is a value of 0 here. So this must be 8 here. So this is 8. Green is here. That's fine, I guess. Can we have a blue? Can we have a green here and a blue here? We could. You could also have blue there. Oh, this 3, 4 that's here obviously sees that cell there. So this can't, and this is the missing 3, 4 in this cage, which would be equal to this cell. So this has to be that 3, 4. So this is, we'll mark this as B, I guess. So B is here, B is here, B cannot be here, this can't be B. So B is one of those two. That's not too helpful. This cannot be B. This has to be the corresponding C. So we have 3, 4 here, 3, 4 here, so this cannot be 3, 4 in the rest of the column. Therefore, this can't be 6, 7. So this cannot be the C 3, 4. It has to be, then C has to be one of these 3. And that matches whichever C is there. This cannot be, this is the C 3, 6, 7 pair. And this can't be B. Right? So the B here is either 3 or 4 with 6 or 7. That means the other 3, 4 has to be one of these. And it has to be one of these two. Well, since it's one of these two, this 3-4 or 3-7 or 4-6 pair cannot be the same as this. And then this B being here means this can't be 3 or 4. So this has to be 8 or 9 here. And this is 1 or 2. Okay. Interesting. So this is 8. This is done. Okay, so maybe we should mark all the boundaries. It does make things clearer about where things are. So this is boundary, this is boundary. A boundary here, and here, and here, and here, and here. Here, here, and here. Okay. 3, 4, 5. This cannot be 1, 7. It could be 2, 6 if this is 2 and this is 6. It cannot be... It could be potentially 3, 5. 3, 5, 4. So that's 4 and 6. So what are we not missing here in box 2? Obviously 1, no 2. Sorry, we have a 1, we have a 2. We have both 3 and 4. We have 5, so we're missing 6, 7, 8, 9 here also. Interesting. So this is the other 6, 7A that is or the 6, 7 here. We're also missing A, which is that. And we're missing this digit here, which I guess we'll mark D. So D is not obviously here, and it cannot be here, so D has to be here. So this is 1A, D, and the other 6, 7. So I guess we'll mark that as E. So this is E also. Interesting. Okay. Let's see. So if 1's here, this is all green, which would make this blue, blue, blue. That seems fine. Can it be blue, blue, blue? Oh, that's interesting. So if this is blue, 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 that makes this green, because we can't have 4 blues in a 2x2 area. Therefore, this would count as 0, so this would have to be valid and blue, and that would force this to be pink, because this would have to be an 8-9 pair. And this would be 3, obviously. This would have to be a 1-2 pair. Which means this could not be 1-5 or 2-4. This is blue and blue, so we have blue and red. Well, this is blue, blue here, which means the blue has to be here, which means this is green. So this would have to be green, green. So green counts here. That means this would be blue. And we have a contradiction here. Because you would have green and green across here from blue and blue. And this cannot be for a orthogonally connected region then. So this cannot be... This cannot be 3 blues. So it's 2 blues here or 2 blues this way. We don't know which. Right, so maybe we try to have blue here and green here. If that's the case, then this forces this to be blue. That seems okay. Um, huh. So this cannot be three blues. It's two blues and a green. So one of these is blue, one of these is green. We're not sure which is which. um, can we ever have these as valid cells? So green is 0 here and here. So if these are three different valid cells, this would be blue, blue. This would have to be pink. So then this would have to be green as the valid cells here, which would make this blue. So since this is blue and this is blue, this would have to be blue there, which would make this green. We'd have three green cells there. We have green, green here. This is green. So this would be green, and this would be a contradiction. Because you'd have this blue, not contradiction, but this blue area would be essentially broken off from every rest of the blue areas. Is that the case? So if these are both pink, oh no, because it could be a cross, right? It's if both of these. So if this is blue here, ever, and this is pink. So if this is ever blue and pink here, this obviously can't be a 2x2 area with this all blue, so this must be green here. And green is the non-zero, so this blue must be the 0 here in box 5, so that would be blue. Then you would have a cross blue here, this would be green, so this would have to be a blue here, which is a valid number, so that would be 1, and then this would not be blue, so that'd be green. But then this would be cross green here, and so this would have to be green there, but then this blue area is stuck. So you cannot have these. One of these must be non-valid. Sorry, must be 0. So that means this must be non-zero. So this is blue. This must be pink. Well, that's not true. We don't know. Um, what happens if pink is green here? If this is green, this is blue. We still have the same problem, right? This is blue crossing here, so this can't be green, green, so this must be blue. Which means this cannot be blue, this is green. You can't also have a green crossing here, which forces this to be blue. So this is the original problem, right? Or no, it can't be blue, it has to be green. And the blue is stuck in the area. So that means pink has to be blue. So this must be blue that way, which means this must be green. So the 0 value is green in box 5. Okay, because of that, we know you can't have blue and blue because this 2x2 area would be all blue then. So one of these is blue, one of these is green. Which means this is an 8-9 pair. We kind of already knew that. Let's see. So we don't have a stuck there. One of these obviously is a blue. Hmm. Hmm. Yeah, that's why I was going down the looking for other contradictions because this looks like again it looks like the correct path, but we don't have assumptions here that we can make yet. This digit cannot be 1, cannot be 2, cannot be 3 or 4. So this has to be 5, 6, 7, or 9. Interesting. Oh. And it can't be 5 and 1. So because of the 3, 4, 3, 4 pair, because it can't be 2, 2, can't be 1, 9 because of the 1 here, this can never be 1 through... you can't have a 2, 4 pair here. So one of these is blue, one of these is green. If we try to have... Huh. Interesting. What does that mean, though? So we have to have a 6 here. Which means this cannot be 6. So this cannot be 4 here. Obviously this can't be 3 or 4. Huh. What are we missing in column? So this is a blue-green pair also. We know 6 is there. One of these is 8 or 9, but we don't know which. 0 cannot be here. 2 cannot be here. And it can't be 6, 8, or 9. So we have 1, 3, 4, 5, and 7 there. 1 can't be there. 4 cannot be here because of a 4 in one of these cells. 1 can't be in the same cage. So if there's a 1 in box 1, it's one of these two. Hmm. If this is 2 digits, it's either 2, 6 or it's 3, 5. Cannot be 1. Or it could just be an 8 by itself with another, with the same... So one of these at least is blue, but we don't know which. You could only have, you could have one, potentially just one blue here. Hmm. Remaining digits in column. Right, there's no 3, 4. This is 2, this is 1. So we have 5 through 9 here. This cannot be... We have C here, so the C 3, 7, 4, 6 can't be here. The B cannot be either of these either, so this can't be the 3, 7, 4, 6. So this is 1, 2, 8, 9. Okay. What else do we have? Um... Hmm. We know B is one of those two. C has to be one of those three. um. Huh. One of these is 8 and 9. That doesn't help us. This is obviously not 1. That's not helpful either. This is... We have a guaranteed 0 here. That means one of these 5 is a 0, and then any of these could be 0. What are we missing in box 9? It could be 1, 4, 5, 6, 7, 9. Okay. Hmm. Hmm. Ah. So if this is 2 digits, it's 2 and 3. Because 1 cannot appear... 1 is here. 1 is here, 1 is here, 1 is here, 1 is here. This could be 1. Or it's 2. If this is 2 digits, it could be 1, 6. That would be 2, 4. You could have a 1. You would not have 1 there. You would have a 1 there. Oh, interesting. So if this is blue, blue here, that means this would have to be green. So then the rest of this would be blue. So let's just go through that pattern. Let's say you have blue, blue here. That would force this to be green. These would then be blue. This would be a 6 then. Oh. Well, no, so then this would be green. Aha! And we probably have a contradiction? Maybe, maybe not. Hard to say. This would not be 7. We'd have 1, 6, or 2, 5 here. It cannot be 2, 5 because we have both of those going that way. So then this would be 1 and 6. This would have to be a 2, 4 pair then. And then we'd have a contradiction because this would have to have a value of 1. But we have already a 1 there. So it cannot go blue there. So it must go blue the other way. So this must be not blue. This is green, which makes this blue. This is blue crossing itself, so this must be blue here. So that means blue is the 0 value. And green has to be the actual value. So this is not 6. This is 6 here. This is 1. This cannot be 1 here. So this is 1, 5 or 2, 4 this way. This is not 1. Okay, so then we have boundaries here. Okay. We have blue, blue. Okay. This is boundary. One of these is a 6. If we had blue here, this would have to be green. This would be blue, blue here, and then therefore this would have to be blue. But then we have a 2x2 area that is all blue. So this cannot be blue. This must be green. So this is green, which forces this not to be green. So this is blue. So this is the 6 here. So we have 6 here. This cannot be 6. This is green. One of these is blue. The other one's green. If we have blue here, if we have blue here, and this is green, that's possible. Okay. One cannot appear here. One can't appear here. We kind of already knew that. Okay. Remaining digits, so this cannot be 1. 2, 3, 4, 5, 7. This is boundary here. One is here, one is here. So that means in column 7, we could have 4, 5, 7, 8, 9. Okay. We have a 3. No, we don't. I was going to say we have a 3, 4, 5, 6, 7, 8 quadruplet, but it's a quintuplet. It's 5 digits possible here. Ugh. This is B. One of these is B. 4 cannot be here. This can't be 4, so since this can't be 4, this can't be 2 here. Hmm. At least one of these is blue. At least obviously one of these is... Well, one of the... Well, not true. You could have green... Green, green. What happens if this is blue? Then that means it's 0 in value. So one of these at least must be blue. And then the other one has to be green. So that would mean a 5 is there. Okay. I mean, that seems possible. What if this is green? Then this could be 5. Okay, this is blocked off. So either this is blue or this is blue, right? That means this has to connect somewhere else. If this is blue, so what happens if this is blue? Then this has to be green. We know one of these is blue, and then it must be a blue-green pair. Let's go the other way. Let's make this assumption. So say this is blue here. That forces this to be green here. This must go out this way, so that's green. Okay, so this is connected. That seems okay. This would then be an 8-9 pair here. Yeah, that seems fine. Hmm. And obviously, if this is... Okay. Oh, that's interesting. Right. So if this is blue, this is green, this has to be green to get out here. If this is blue and this is green... Sorry, other way around. If this is green and this is blue, this is a 2x2 area, which forces that to be green. So either way, this has to be green. That's interesting. So this is not valid. So the question is, so either this is 2 and 3 as a pair, or it's 5. That's interesting. Huh. No, it can't. Okay, so this cannot be. So if this were 2 and 3, this would be green and this would be blue. But you'd have a crossing, you'd have two diagonals essentially being opposite sets, which means they can't connect. So this cannot be 2, 3, therefore this is a 5, which means this cannot be 5 here. It's 3, 4 as a pair, so this is A. Or not A, this is whichever one, C. So this is C. This is 5. If we have, we cannot have, we could have 2 greens. It's either 2 greens or 2 blues. We don't know which. Can it be 2 blues? Maybe? If it's 2 blues, this would be a 5. No, this would be the 5. Right? Okay, this can't be 6 for one thing. So in row 4, we have 2, 1, 2, 6, 7, 8, 9 as the possible digit that's not there. It can't be 1 because we have a 1 guaranteed here and a 1 guaranteed here. So if it's 2 blues, obviously this goes out. If it's 2 greens, so if it's 2 blues, this must go that way to connect. So that's green. If this is 2 greens, then this becomes a blue. Which would make that blue. Okay, let's try. Say this was 2 blues. This is 2 blues. This must connect this way. So this would be green, not green. So it'd have to connect here. That would be green, and we have a blue there. Okay. This would have to go that way. And one of these would have to be, one of these would have to be. So that's possible. Okay. That's not helpful. What happens if both of these... So both... Okay, if this is green, this can't be green because of the 2x2 area. So this would be blue, which means this can't be blue, that's green. This has to connect, so that would be blue. Okay, so that's very different. Okay, not helpful there. What happens? What happens if both of these are blue? If both of these are blue, this can't be blue. This is green, which means this can't be green. That's blue, and we have a contradiction because we have the diagonals being blue and green, so different sets, which is impossible. So this cannot be blue and blue. One of these is blue, one of these is green, so we have an 8 there. So we have an 8 here, which means this cannot be 8. So A cannot be 8, obviously. Can you have a blue being here? So say this is blue. This would not be blue. Sorry. Yeah, this would not be blue, so this would be green. We have blue on the diagonal here, so this can't be blue. This can't be green. This can't be blue then. That's green. Blue on diagonal here, so this can't be green. That's blue, which means this can't be blue. Ah, and then we'd have a contradiction because this would have to be 1 as a blue, and this would have to be 1 as a blue. So that cannot be that way. So this can't be blue. This has to be green. So this is green, which means this can't be green. That's blue. That's there. We have an 8 here, which eliminates 8 here. So this is done this way. One of these is blue, the other one's green. That's interesting. And it depends on where the 1 is. That's interesting. Okay. This obviously can't be 8. It could be 9. Hmm. This could be blue or green. Great. Huh. This digit can be 3, 4, 5, 6, 7, 9. Not helpful. Okay. Huh. 2, 4, 5, 6, 7, 8, 9. There's possibilities. So it connects to one of these. So if it's blue, blue here, then again, the green has to get out. So that's green. This would not be green. So this would be 1. Which means this couldn't be 1, so this couldn't be blue. So I go that way. That seems fine. Yeah, seems fine. Obviously, you go that way. This would have to be 1, 6, or 2, 5 here. Huh. Where are the zeros? Well, 0 could match any of these. 0 can match here, but it cannot be here. 0 could be here or here. Any of these. 0 in box 8. It's one of these. Oh, this is 6, which means this cannot be 6 here. So this is a 3-7 pair. There we go. Okay, so this is 3-7 as a pair, which eliminates 3-7 here. All the B's, well, not helpful there, are 4s. All the E's are 6s. So E cannot be here. E is one of these two. So this is 6. So we are not missing a 6 in B, in box 2 or box 4. A cannot be 6. We have a 7, 8, 9 triplets in the missing digits in boxes 2, 3, and 6. So that eliminates 7, 8, and 9 of the rest of the missing boxes. That means we have to have a 9 here somewhere. We have to have a 9 here somewhere. We have to have an 8 here somewhere, too. 8 cannot be here or here. This is 4, which makes this not 4, so this is 3. That eliminates 3 here. This is a 4-5 pair. This is a 3-7 pair. Rest of column 5 can be 0, 5, 8, or 9. And then we have 2 here. And this is 1. 8 cannot be here. So we're missing, it cannot be 1, 2, 3, could be 5. Could be no 1, 2, 3, 4. Could be 5, no 6, no 7, 8, or 9. We're missing 5, 8, or 9 here. We're not missing 4 in box 4. Sorry, box 5. Remaining digits are 1 through 6, 1 through 6, 1 through 6 in the boxes. We have to have a 2 in box 3. We have to have 4 and 5. So 4 cannot be here, 4 cannot be here in box 3. So 4 has to be one of these two. 5 could be either of these. 6 can be any of those. So 2 has to be here, which means this can't be 2. What else are we missing? We know there's a 6 here, so that we can remove E. 6. We can label this beast it now. But that's not that helpful. A and D are here, obviously. B and D have to be here. A is there. So A is not anywhere in box 3. A can't be here. A is one of these. A is one of these. Okay, so because we are missing a 1 through 6 in boxes 7, 8, and 9, these also have to be 1 through 6, right? You're not missing a 7, 8, and 9 because 7, 8, and 9 must appear in each of the boxes. So therefore, this is... Okay, so this can't be 3 or 6 here. This can't be 2. Okay. 8 must appear one of those 3. 4. Can't be here, so it's one of these 3. So we know 8 is one of these 3. 8, 9 cannot be here. 8 and 9 cannot be here. So 8 and 9 both have to be in these 4. Hmm. 9 has to be one of these. Okay, so remaining digits in row 8. We have 0, 1, 2, 4, 5, 7, 9. Okay, so this can't be 1 because of 1 in the column. 0, 1, 2, 4, 5, 7, 9. 0, 1, 2, 4, 5, 7, 9. 0, 1, 2, 4, 5, 7, 9. No 4 here because of 4 in the column. No 1 here because of 1 in the column. Okay. So B obviously has to be one of these. That's not helpful. We know A and D are here. We know 4 is here. So this cannot not have a 4. Mm. 1, 4, 6. So this is 2, 3, 5, 7, 8, 9 as possibilities. Oh boy. Yeah, this is definitely very hard. Going through this is kind of... Okay, so if this is 1, that's 6. And then this becomes an AD pair. Oh, that's interesting. Then this would have to be B. Huh. Remaining digits here. We have no 1, 2, 3, 4, 5, 7, 8, 9 as possibilities. One of these is B. We are whatever. It's 4, 4, 5. We already know that. This is 4. 8's one of these 4. Okay. This can't be 2 because it's... Oh, it cannot be 0 either. Aha! This 0 is in this cage, so it cannot be here, so therefore this must be 0 here. Okay. Which means we have to have a 0 either here or here. Okay. Huh. 0 could be here, or 0 could be any of these, or 0 could be there. This can't be 4 or 5 because of the 4, 5 pair in the column. Hmm. Hmm. This must be missing. So this 0 in this column must be missing an A or a B. Because if it's not, then it's missing the 4, 5. I guess they could be missing each other's. Okay, never mind. That could be possible. Interesting. Okay. This has to be 1, 2, 3, 5, 7, or 9. 2, 3, 4, 5, 7, 8, 9. Oof, this is hairy. One of these two is an 8. We don't know which, because this can't be 8 here. But that doesn't help very much. Oh, interesting. This cannot be 8 and 9 here. This can only have one out of 8 or 9 here because we have an 8 or 9 here. So therefore, we have to have 8 or 9 here. But if this was 8, the problem is this would not function to add up to 17 because we need an 8 here. So in this cage, one of the 8 or 9s must be along these three. And it cannot, this therefore, this therefore must match with one of these two. And it cannot be 8 here, and it cannot be 8 here, so this must be a 9. So this is guaranteed to be 9 here. You cannot have an 8 in either spot, so 8 has to be one of these 4, which means this can't be 8. This is 9 and 1. So this is 9 and 1, which eliminates 9 in the rest of the column. So this cannot be 9. This can't be missing 9. This can't be missing 1. No 1 here, obviously, and no 1 or 6 here. This can't be 1 here. No 1 or 9 here. No 9 here. So we have an 8 here guaranteed. 9 cannot be here, so 9 is one of these two, but that doesn't really tell us very much. We know, oh, 9 cannot be here, and can't be here. Where's the 9 in this cage, which we have to have? It has to be here. So that eliminates 9 from being here. This can't be 9. This must be an 8. So this is 8, which eliminates 8 here. So this, where's 8 in box 8, which it has to be, because again, we have 7, 8, 9 missing in already box 2, 3, and 6. So this has to be 8 here. So this is 8 here. We don't know if the 8s are there. This is 0, 5, or 8 as the other digit. This is 8 here. 9 is here. 9 cannot be here, so this must be a 9 to add up to 17 and must be blue. So this is blue. This cannot be blue. This is green. That means this is boundary this way, boundary this way, boundary this way. This cannot have a 9 missing. So it has a 6 missing. So 6 can't be here, 6 can't be here, 6 can't be here. So this must be a 6 missing here. Okay. Which eliminates 6 in the rest of the missing cells in rows. One of these is 5, so this cannot be 5 here. Again, you cannot have, if you try to have this, So if you try to have both of these being set, yeah, this 3x3, this 2x2 box has 3 blues, so therefore this can't be blue. So that's green, which means it's 0 in value. If you try to have both of these have value, this would be blue and this would be green, and then you have the cross-diagonal problem. So either both of these are blue or both of these are green. Okay. 9 is here. Remaining digits in box 4. We have 0, 2, 3, 4, 5, 7. This can't be 5, 3, or 4. 0, 2, 3, 4, 5, 7. No 3 or 4 there. 0, 2, 3, 4, 5, 7. No 4 here. Okay, so if there's a 4 in box 4, it has to be here. This must be specifically 1, 7, 8, 9 here. So this is 1, 7, 8, 9. This is 1, 6, 7, 8, 9. Obviously no 8 because of 8 in the column. Okay, so we can just remove these outer stuff. It's a little too busy for my purposes. Zero is in blue here. It's in green here. We already have the 0 here. 0 is one of those two. We need a 6 in this cage here. So 6 has to be one of these two. Which means in box 7, we're not missing a 6. In one of these is a 6 guaranteed here. So we don't have a 6 here, we don't have a 6 here, we don't have a 6 here in box 5, so in box 5, we are missing a 6. Which means we cannot have 6s missing in the rest of the boxes. So we have to have a 6 somewhere here. So the 6 in box 9 has to be one of these two. Okay, we have to have a 6 in box 1, so it's one of these 4. We have to have a 6 in box 3, so it has to be one of these 4. Okay. So we're not missing 6 in column. We are missing a 6 in column 4. So this is a 6 that we're missing. This can't be 1. I don't know how I had a 1 there. In column 1. Okay, let's remove the outside stuff here. So remaining digits in box 2. We have... So this is 6 here. We're missing 0, 2, 3, 5, 7, 8, 9. 2, 3, 5, 7, 8, 9. 0, 2, 3, 5, 7, 8, 9. No 3 here. No 8 or 9 here. No 8 or 9 here. No 8 here. 2 cannot be in the rest of the box because we know 2 has to be one of these two. Add up to 3 for this cage. Three has to be one of these two here. So we know we have a guaranteed 3 here. 5 has to be one of these 5. 2 obviously is one of those 2. We don't know about 7, 8, or 9, though. Okay, we can remove the outer stuff here. I guess we just leave it there. We can remove the C's. We don't really care about that. Remaining digits in box 5. 0, 2, 3, 5, 6, or 7. 0, 2, 3, 5, 6, or 7. This can't be 6 because of the 6 is missing in column 4. Remaining digits in column 4 have to be 0, 2, 3, 4, 5, or 7. And this can't be 2 because of 2 in the row. This is guaranteed to have a 4 here because there's no other place for it. So this cannot be missing a 4. This digit cannot be 8 and cannot be any part of these. It could be 1. So this could be 1 and it could be one of these digits. So it could be 0. 1 or 0. This is missing 1 through 7, but no 6, obviously. So 0, 1, it cannot be 2. Could be 3, 5, or 7. Okay. This can't be 5 because one of these two is a 5. So one of these digits is a 6. What's the other digit? It has to be whatever digit is there, right? All of these digits see this cell, and this cell is an 8, which that can't be. So this must be 0, 2, 6, or 7 here. Remainder of box 2. Sorry, column 2. We have 0 through 7. 0 through 7. This can't be 1, 4, or 6. This could be any of those still. There's no 4 in here. So we have to have a 7 here. We have to have a 7 here. Oh, this can't be 6. Remaining digits of column, actually box 8. We have 0, 2, 3, 4, 5, 7. Right? No 2 and no 4 here. Okay. Oh boy. This digit cannot be 4. That's all we know. 1, 2, 3, 5, 6, 7, 8, 9. This digit cannot be 8. That's all we... And no 4. 5, no 6. Oh, there's no 6s either. 1, 2, 3, 5, 7, 9. No 4, 6, or 8. 0 is missing a 6 here. So obviously this can't be 6, and this can't be 6 either. We already have all 6s here. Okay. Hmm. uh, yeah, I'm trying to figure out the disambiguation here. I don't know if we have very much of it. Oh, this is a 4 here. So this cannot be 4 here. Okay, there we go. So this can't be 4. Where is the 4 in this cage to add up to 4? It must be here. And it must be non-zero, so this is not blue, this is green, which makes this not green, that's blue. That doesn't help very much. Because that doesn't disambiguate anything. Because it satisfies both blue and green here. Oh, this is green, so this must cut that. Oh, it could be blue that way. Frig! Okay, so that still doesn't give us anything. Okay. Hmm. Oh, we need a 9 in box 1. So it has to be one of these two. We need an 8 in box 1. It has to be one of these 3. um, Man, that's a lot of huh. We need a 6, we have a 4. Oh. One of these two is blue, but it could be blue, blue here, and green, green. Huh. This is definitely very hard. Logic is pretty cool, but it's just it is very difficult. um, uh, um, hmm. Huh. Hmm. Okay. I'm not missing anything? I don't think so. Uh, okay. Um, hmm. This can't be 7. If that were a 7, then this would not be 7. And this would have to have a value of 0. This would be some value plus 7 would not add up to 7. And obviously 0 plus some value, not 7, does not add up to 7. Huh. This could be something like 6, 7. 0 can't be here, 0 can't be here. Oh. 0 is in every cage, or every box. It could be 0 here. Dang it. Again, this digit has to be one of these two. Or 1. Could be 1. Right. So this has to match one of these 3 cells in the cage. But we don't know which. Um, hmm. I think we just have to try these different ones, right? And see if we can get a contradiction. Because it's not right now running. 4 is not missing here. In rows 1 through 3. One of these two is a 9. That's interesting. One of these 3 here is a 9. But that doesn't really help us much, right? 9 can't be here. We know we're not missing a 9 in box 9. Okay, so we're not missing an 8 in column 7. We're guaranteed a 1 there. We have to have an 8 here, so it's one of these 5. We have to have a 2, so the 2's over here. Huh. Okay, let's just try something. I don't know. You cannot in columns 1 through 3. Sorry, no. Yeah, columns 1 through 3, or box 1, 4, and 7, you cannot be missing a 7, 8, or 9. So no 7, 8, no 7, no 7, or 9. Hmm. 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 These are the same row, so it doesn't matter. These are the same box, so it doesn't matter. And nothing else matters. Yeah, I think we just have to try it. Blue, that forces this not to be blue, so that's green. That forces this not to be green, so it's blue. Which means this has to be blue here. This is not blue here. Could be either one here. This has to connect here. So, what does that mean? That means this is value 0. This must be a 5. That makes that interesting. So no 5 here. This is a 0, 1 pair, which eliminates 0 and 1 in the rest of the column. In the rest of the box, this cannot be 5. So 2 has to be, this can't be 5, obviously. This is a 0, 1 pair. We have to have a 5 in this box. Obviously, this can't be 5 anymore. So far that's okay. This is a 1. Let's actually do the other way around. Okay, what if this is... Okay. What if this is blue, and then this is not blue? So then this would have to be not blue because it cannot be 1, and this would be blue. So, okay, whoops. So again, if this is not blue, no, so this is blue. Therefore, this is not blue. This has to be the 1. So that forces this to be 0, which means this cannot be blue. It's green, which means this can't be green. That's blue. So this is 1. This is green. This has to be green then here, which makes this green here. Okay. So obviously these can't be 0. This can't be 5 because it has a value of 0 here, and this must be a 5 here. So this would be 5, this would be 6, this cannot be 1. We have a 7, 8, 9 triplet in row 5 then in that case. This can't be, we couldn't have a 3 anyways there. So, okay. This couldn't be 3 anyways. Again, we'll try to have that. So this be blue, no blue, that's green. This blue, this is blue as a 1. So this is 6, this can't be 1 here. This is 0, which forces this to be 1. Cannot be blue, it's green. This can't be green, it's blue. The green has to go out, so it must go to here. This can't be green because of the 3 greens there, so this must be blue, which means this can't be blue. This is green, this must be a 2. No 0 here. No 0 here. This can't be 5 because it has a value of 0. So this must be a 5 here and is green. This blue must connect out, so this must be blue that way. So then this has a value of 0, so this must be 7. Which means this can't be 7, that's 9. This can't be 1. So the 9 must be missing in box 3 in that case. Okay. So this must be 9. Which means this cannot be 9 here. This cannot be 9 here. So one of these two is 9, which means this cannot be 9. So this is 8, that's 9. Oops. This is 8, that's 9. This can't be 0. No 5 here, no 5 here, no 5 here. We're missing a 5 in... We're missing a 5 in this cage. Because it can't be here, it can't be here, so it must be here. Therefore, this can't be 5, therefore that's 2 and 4. I mean, so far it's looking fine. We need a 0 in box 4, so this must be 0 here. This can't be 4, this becomes a 3-7 pair. Which, and then we have a contradiction here. There we go. So, this cannot be 1. That was a long, convoluted way of showing this couldn't be 1, but okay. Yeah, because we would have to have a 5 here. This couldn't be 1, 5. It'd be 2, 4. That would eliminate the 4 here. The 5 here would eliminate 5 here. So, we know this can't be blue. This has to be green. And since this is green, this is blue, which forces this to be 1. So this can't be 1 here. Which means this must be 1 here. So this is blue. No green. This can't be blue here. This is green. So we have 1 here, 1 here. Okay. This is so convoluted. Boundary here. This could be both blues or it could be both greens. No, it cannot be both greens. If this is both greens, only one of these is blue, and then it cannot connect to the rest of the area. So this must be both blue. And this is value 0, so this can't be 5 here, so this must be 5 here. Okay. That means 5 is eliminated from the rest of column 4. This can't be 5, so this must be 0. There we go. So this cannot be 0 here. No 0, 5, no 0. Okay, so then this is done. Done. The green must connect, so this is green. So this is done here, and we don't know which one of these two is a 2. Okay. This is so convoluted. Anyways, 0 cannot be here. We are missing a 0 in the cage of this cage here, this one cage. So this cannot be 0 here. We need to have a 0 in one of these 5 cells. So we have to have a 0 in here or here. Whatever digit's missing here. So whatever digit is here. Whatever pair is here must be in this set. So whatever pair is here is in this set. The 8 is here. This digit must be one of these 4, but it cannot be that one. And the digit that's missing here has to also be here. Interesting. We are, well, 7 could be here. Okay. This is 2 digits adding up to 7, so it cannot be 7. So this is no 3. This is either 1, 6 or 2, 5. So this cannot be a 6 here. So 6 has to be one of these 2. Interesting. So we're guaranteed a 6 here. This must be the other digit, 0, 2, or 7. Because this digit sees all of these cells, and it cannot be an 8. So it has to be one of these 5. But it sees those cells too. So it has to be one of those 2. Okay, we are getting somewhere. I don't know where. Um. Uh, uh, so 2 is guaranteed to be one. Ah, there we go. 2 is guaranteed to be one of these two, which means this cannot be 2 here. Where is the 2 in this cage then? It cannot be here. It cannot be here, so it must be in box 7, which means this cannot be 2. So this must be a 1-5 pair. Which eliminates 1-5 in the rest of the column and box and this is guaranteed to have a 1 and a 5 then. So we are not missing a 5 in box 4. So this is a 1-5 pair. So we have to have 2 here. We could be missing 4 here. So this is guaranteed to have a 5. Okay. This is 1, 6, or 2, 5 here. And this is 1 or 5 here, which eliminates 1 and 5 in the rest of the column then, because we have all 1-5s accounted for. So this can't be missing 1 or 5. It's missing 2, 3, or 4 here. Okay. Oh boy. Where is the 4 in column 2? Cannot be here because of 4 in the box. Can't be here because it's 8 and 9 pair. Can't be here because this must match one of these 3, which is not 4. And this must match 6 or 0, 2, and 7, which is not 4. So 4 has to be here. So this is 4, which makes this 5, which makes that 4. 5 eliminates 5 here, so this must be 5 here. This can't be missing 4 or 5 then. This 5 eliminates 5 here. So this is 1, this is 5. This cannot be 2 and 5, it's 1 and 6. So 6 cannot be here. 6 cannot be here. Where is 6 in this box? It has to be here. Or sorry, in this cage. It has to be here. So this 3-7 matches that 3-7. We don't have a 4 in this cage. We don't have a 4 in the rest of this box. So we're missing a 4 in box 7. So this is 4, which eliminates 4 in the rest of the boxes that we're missing. So that means we're missing 4 specifically in column 1. So this is 4, which eliminates 4 from the cells that we're missing there. 4 has to be one of 7, 8, or 9 that we're missing. We don't know which. Right. 4 is one of those. 4 is one of those. This is 1 and 6. We have 0, 2, 3, and 7. This has to... Okay, remaining digits in box 7 are 0, 2, 3, 7, and 9. 0, 2, 3, 7. This cannot be 9, though. Okay. We are not missing a 1 in box 1, either. Well, where are we missing the 1, then? It has to be in box 9. So this is 1. That means it's in column 9 also. And it has to be one of these two. So this can't be 1 here. It cannot be 1 here. So therefore, and this can't be 5. So we're missing 2 or 4 in row 8. We're missing 1 in row 7. Remaining digits. So we have to have a 5 somewhere in column 1. Okay. And since we have a 5 in column 1, we cannot be missing a 5 in box 1. So we're missing a 5 in box 8. So that means this cannot be missing 1 or 5. It's 2 or 3. We can't be missing 2 or 3 in any other row or column. We have to have 4 and 5 missing in boxes 7, 8, 9. So that corresponds to this. So this must be missing a 4. This must be missing a 5. So no 5 here, no 5 here, no 5 here. So we have to have a 4 somewhere in row 9. We cannot have a 4 here. So we have a 0, 2, 7, 9 quadruplet. Therefore, where's the 4 in box 8? It has to be here. So this is 4. Okay. This cannot be 0. If this was 0, it's missing both a 4 in the column and the 4 in the row. So this is not 0. Which means, where is the 0 in... Oh, we're missing a 5 again in... Where's the 0 in row 8? It has to be here, one of these two. So this cannot be 0 here. This is a 3, 7 pair, which eliminates 3 and 7 in the rest of the box. So this is a 0, 2 pair, which eliminates 0 and 2 in the rest of the row. So it can't be 2. Wait, we have a 3, 7, 3, 7. Ah, no, we have a contradiction. Oh, no, 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 no. Oh, that's bad. That's bad. That's bad. That's bad. Wait, why couldn't this be 5? Maybe that's... No, this is 1, 5 still. That's problematic. This is 3, 7 as a pair, which eliminates 3, 7. Oh, no. Which means there's 0 here, which means this can't be 0, which means that would be 0, but that's 4 and 4. Oh, no. No. Shoot. I don't know where to start. Where it messed up. We're gonna have to stop this for now. And I have to go redo this tomorrow. Because I don't know where I messed up. Well, we have the logic here now, which is good. We just have to go through with a finer tooth comb to make sure we don't mess it up, which we obviously did somewhere. I just don't know where. And it's getting darker, so I'm not really sure. I don't know if I'm going to be able to do that very quickly, and I don't think it's going to work that way. Okay, we'll stop it for now, but we're almost there. Stay tuned. We're going to have basically a second part here. And, well, we will get this eventually. It's just, it might take a while. We'll be back. Actually, for you, it'll just basically be the next video. So, but I'm going to take a break right now because it's getting too dark. And we'll start this up tomorrow for me. Okay, well, we're close. We'll be there. I'll see you in the next video then. Take care.